In Proposition 4, Euclid talks about two triangles of the exact same size. Well, how are you going to make two triangles of the exact same size? Alright, first of all, you're going to draw a line called AB. And then you're going to put a point over here called D. Now, if you remember from Proposition 2, we're going to make an equilateral triangle, APD. Alright? When we do, we're going to put our compass on centermost part P right here, outermost edge B, and we're going to strike an arc from PB to PQ. That means, due to the fact that all radii of a circle are equal, PB and PQ are going to be exactly the same size. Alright? And then what we're going to do is we're going to make D the centermost part of yet another circle, Q the outermost edge, and we're going to strike yet another arc from DQ to DE. Alright, now we've said that PB equals PQ. And we know that PA equals PD. Alright, so AB equals DQ because you remove equals from equals, the rest of it's also going to be equal. Alright? Now, we know that DQ equals DE because all radii of a circle are equal. So now, PB equals PQ, AB equals DQ, and now DQ equals DE, so AB equals DE. Now you have your first line. What about your second line? Well, we're going to strike an arc, centermost part A, outermost part C, to point U. And then we're going to strike an arc from centermost part P to outermost part U, and we're going to make another arc to point V. Alright? Now we have a length that is equal from A to C because AC equals AU. We've now said that PU equals PV, so point D to point V is equal in length to AC. Alright, so now we got that part settled. But why aren't we drawing this from here to here? Because we have one more line that we have to draw from here to here, and it's already been drawn from here to here, but we also have to draw from here to here, and it has to be equal in length. How do we achieve that? Well, we're going to make equilateral triangle BRE. And then we're going to strike an arc with centermost B, outermost C, to S. So now BS equals BC. Then we're going to take our centermost part R, outermost part S, we're going to strike yet another arc to T. Alright, so now we know that ET equals BS and BS equals BC. Alright, so how do we get point F? Well, we're going to take centermost E, outermost edge T right here, we're going to strike one arc. Then we're going to take centermost part D, outermost edge V, and we're going to strike yet another arc, and wherever those two arcs come together, that's going to be point F. Now we can say BC equals EF because BS equals BC, and BS equals ET, and ET equals EF. Alright? And that's because all radii of a circle are equal. We can also say that DF equals DV, and of course, that was established because we had PV equaling PU, and since PA equals PD, and we separated that out, AU, of course, equals DV. And since AU equals DV, then DF equals DV because all radii of a circle are equal. So now you have two circles of the same size. They're not equilateral. They're not even really isosceles, but that's what you've got. Alright? Now, let's go into the actual proof itself. Alright, and we're going to go into the actual proof. Now what Euclid says is very simple. He says that you have two triangles here. He says that AB equals DE, and he says that AC equals DF. Alright? He also says that angle BAC equals angle EDF. Alright? Now, if you were to place this triangle on top of this triangle, point A and point D would coincide, point B and point E would coincide, and point C and point F would coincide. Now he's saying that if they didn't coincide like that, you would have this base and this base coming together and forming an area inside these two lines. Two straight lines will never form an area. Okay? Now you can have a straight line and a curved line that will form an area, but two straight lines will not, there will not be anything sandwiched in between two straight lines. You can do that with 3 straight lines, 4 straight lines. Obviously you can do it with 3 straight lines because there's a bunch of middle area here. 4 straight lines, so on and so forth. But 2 straight lines will never form anything in the center. And that's what he's saying. So, he is now saying that these two triangles are exactly the same size. Angle BAC equals angle EDF. Angle ACB equals angle DFE. And angle ABC equals DEF. And there you have it. Proposition 4. I will talk about more math terms and computer terms in a future video, so stay tuned.